So do you guys see any screen or no? You don't see anything on the slides. Give me a second. I'm just trying to share the screen. 2 monitors, share screen. Okay. Screen 1, screen 2. Oh. I'm just trying to see what different combinations I can show on the screen. So, okay, that's good. So you can see the screen, right? So that's good. I'll just go to the first slide.
Yes, can I blow this up to a full screen?
No, I just connected. Give me 1 second. Okay, I'm just trying to adjust this. Give me 1 second. All right, that's good. I think you guys can see the screen, right?
Yes.
Okay, so good morning, everyone. Thanks for joining our electrical safety panel discussion this morning. I have online John Kolak, President of Praxis Corporation, and also Charlie Miller, who is electrical safety trainer and NEC expert, joining us this morning. And I'm Banu Srila, Director of Technical Marketing here at Grace Engineered Products. Okay, so what we'll be doing today is this 2 hours live event where we'll be talking about different questions from our end users who have asked us on several safety topics and also code compliance elements within the electrical safety. And we have 2 experts here with us this morning, and we will do this for 2 hours. So what we're going to ask is, as you are going through this presentation or this live stream, please do share this with your channel of the connections. So if you have any of your customers or your colleagues who would be interested to learn more about electrical safety or would like to hear or get answers to any of those safety questions on electrical side, they'll be also able to type in those questions during the live stream, and we'll address them. We'll be just taking a few questions on the start, what we have from our earlier discussions, and then as we are going through the live stream, please do type in the questions and we'll be answering them as well. Okay, so without the delay, I'll just go to the next slide. So this is a disclaimer. I want to read this out clearly because all this responses to the questions and the views and opinions expressed during this webinar, electrical safety panel discussion, are those of the speakers based on their professional level. We're just taking a few questions on the start, what we have from our earlier discussions, and then as we are going through the live stream, please do type in the questions and we'll be answering them as well. Okay, so without the delay, I'll just go to the next slide. So this is a disclaimer. I want to read this out. Can you hear me? There's all this responses to the questions and the views and opinions expressed during this webinar. We're going to get back here on those of the speakers based on their professional level. Questions and start what we have from our earlier discussions, and then as we are going through the live stream, please do type in the questions and we'll be answering them as well. Okay, so without the delay, I'll just go to the next slide. So this is a disclaimer. I want to read this out. Can you hear me? All this responses to the questions and the views and opinions expressed during this webinar. Can you hear me? Those are the speakers based on the professional level, problems and start what we have our earlier discussions. Can you hear me? I can't hear you anymore. Please do type in the questions and we'll jump in the next one. Okay?
Hey, Banu.
Yeah. So this disclaimer, can you hear me?
Yeah.
I can hear you, John. Can you hear me?
Banu.
Yeah. Can you hear me?
Banu, your audio is.
I can't hear you.
Hey, Banu.
Yeah, I can hear you.
Okay, your audio sounds like you're in a garbage can. I can't understand you.
That's what I'm just having a problem here. I don't know what's going on. Give me a second.
Okay.
Can you hear me now?
Yeah, that sounds better.
Okay, I know what happened. Okay.
Okay, good.
The responses to the questions and the views and opinions expressed during this webinar are those of the speakers based on the professional level and personal capacity, and does not reflect the position of the organizations or other committees that present. The recommendations and any suggestions provided during the webinar session are purely for informational purposes and cannot be used in the real-world applications without a detailed consent, analysis, and written authorization from the presenters. By participating in these discussions, the attendees consent to waive all the liabilities arising from the use of information presented and any misuse of information that could result in a personal injury, property damage, or any other negative consequences on the presenters and the organizations that present. You guys can clear all this, right? So I don't have any ability to see this. Okay. So I'll go to the next slide here. So additional information, as I told you before, please submit the questions using the comment sections during the live stream, using the LinkedIn platform or a Facebook or a YouTube platforms that you're watching this currently. And further, please do share the event while you're watching and let your connections also know that if they have any questions, they'll be able to join and watch this live stream as well. Okay. So hit the like button and follow us on the social media platforms. This applies to all LinkedIn, Facebook, and also YouTube watchers who are watching this currently. Okay, thank you so much. So the first question, what rules apply to working on electrical panels live in regard to safety to others around? So.
All right. There are several things. For one thing, we have alerting techniques. Those provisions are in 130.7E, and it says where it's the title of the section is alerting techniques to warn employees, but it does say where necessary. That in itself is not a requirement. It does cover safety signs and tags, barricades, and attendance. There's also in for shock 130.4E. And E1 and E2, there's a warning to warn unqualified persons that there is a shock hazard, and there's also a requirement to warn them to stay out of the limited approach boundary. There also may be in a company and their specific electrical safety policy to put up barricades or have an attendant have at least one additional person. So it really depends on the company. We find some of the requirements in 70E, but I've seen a lot of other requirements that are more specific, more restrictive in a company's electrical safety policy.
Okay, thanks, Charlie. The next question what we had is, appropriate test equipments could be location dependent, which is like voltage rating. Would this be handled by training and documented by who? So John, do you want to start with this?
Sure. Requirements for test equipment and all that is part of the training process. And it is dependent not only on the voltage level of the equipment. For example, there's differences in the testing equipment we would use on high voltage systems and low voltage. And we'll define low voltage as 600 volts and below in this case. So there's certainly requirements for that, but it's also dependent on if you're using it in like in an explosive environment or a wet environment. All of that is covered by some sort of a training guide that you would have. So it's actually a line item that needs to be checked off, meaning that someone has demonstrated proficiency in these. And again, year in and year out, voltage testing and that sort of testing is one of the leading causes of arc flash events that happen, and shock events as well. So yes, it is covered by training.
Okay. So John, here is my question. Do you also want to add anything about the category of the application, like category 4, 3, and 2 different levels when you look at industrial facilities?
Yeah, absolutely. But part of the test requirements for somebody to be certified in that is that they do understand the category or CAT rating system. And that's a system basically, it's an international standard. The IEC, International Electrotechnical Commission, came up with it. But basically, it's a 4-category system. Category 1 would be the against is essentially an overvoltage situation, or perhaps in some cases an arc flash event. But the Cat 1 is basically an electronics technician would use that. A Cat 2 rated meter would be something that would be used more by like a residential electrician. Cat 3 is anything that's permanently mounted. If it's bolted to the floor, bolted to the wall, it's Cat 3. And Cat 3 will go all the way up 2, but not including on the utility system, the incoming utility power. If you're going to be working on that part of the system, it needs to be a Cat 4 rated meter. And the category system not only applies to the meter, but also to the test leads and any other appendage that goes onto the equipment. It all has to have a Cat rating. And that is there to protect the user against overvoltage and overcurrent situations.
Okay. Thanks, John. I just want to make sure that I have the screen that I'm presenting here. So the next question is, so what are the separation requirements for line, power and control, 24 volts DC for arc flash?
All right, so this is not addressed really in 70E. This is more, as far as the separation requirements, we would need to look in the National Electrical Code. If it's for certain conductors, like, for example, class 2 and class 3, we do have separation requirements. We find those in Article 725 of the National Electrical Code. And of course, that would apply to installations and industrial control panels and other electrical equipment as well.
Okay. So the next question here is, how to politely inform workers that they are not qualified to perform complex tasks on electrical equipment. So this is for you, John.
Well, I don't know that you need to be polite about it. I think, of course, management is required to assign people for work that they're well qualified to do. So we have to know what they know, and that's accomplished by testing both. Testing in a classroom, cognitive testing, as well as what they'll call demonstrated proficiency. You have to be able to demonstrate how to use these things properly out in the field. And so in that sense, let me go back. I lost the slide, Banu, that you had on that one. What was the question again?
So give me 1 second. I'm just going to put the slide back. So how politely to inform the workers that they are not qualified to perform the complex tasks? Yeah,
I guess, again, the way that I always recommend that any supervisor or anyone approach it is that you're going to query them as to what the problem is, whether they understand what to do or not. If they're not qualified to do it, of course, we're not going to let them do that work, and they're going to be working under the direct supervision of somebody who is properly trained, and they would have to be observed and eventually signed up. But again, I don't, at this stage of the game, we can't risk anyone's life. We can't allow these things to happen. So I don't know that politeness is in order. What I think is in order is direct communication, and also letting them know that the reason for your concern is for their safety, that we're not doing something to be heavy-handed, but we just simply can't allow people to work on systems for which they're not well qualified. So that's normally what I recommend, that we approach it. And as a foreman or as a supervisor, that's what I did. If I had somebody who wasn't qualified, I was very direct about it. I was clear as to what we needed to do to get them qualified to do the task. And I only let them work under direct supervision until they are qualified.
Okay. Thanks, John. So the next question here is, Is it energized work if I open the box and there are energized THHN wires in the box, but no splices? This is for you, Charlie, from your experience on training safety guys and such. So.
We have to determine, is there a shock hazard? Is there an arc flash hazard? The wording of this question is just talking about a junction box, maybe a pull box with conductors in the box that aren't even spliced. There are no connections there. It's just a conductor that's going through, either straight through or looped through. And is there a shock hazard? No. Is there an arc flash hazard? No. Even if it is a junction point and there are connections, as long as the connections, for example, smaller conductors like number 12 or number 10 wire, if they're under wire connectors, which we typically call wire nuts, then there still is no shock hazard as long as the wire connector is in place and on the conductor.
Okay. Thanks, Charlie. So the next question here is, how often should you run electrical safety audits on your electrical crews? This is for you, John. Okay.
Well, there's essentially two requirements. Some of them come from OSHA, some come from the 7E. There's also what OSHA would call regular supervision. That's all part of the process. But the auditing process exists on two levels. There's a 3-year essentially review process of the 7E requirement, but there's also an annual requirement under OSHA for auditing the program. And what we're auditing the program for is effectiveness. That's the key part of what we're trying to accomplish. It's not good enough to have a state-of-the-art program. It's also got to be effectively implemented. And so there's an annual audit requirement under OSHA for that. Then there's the 7E requirement, which has a 3-year cyclical requirement for reviewing the document itself. And then OSHA has what they call regular supervision. And this means that OSHA expects a supervisor to observe the work on a daily basis. They're supposed to see their supervisor observe the work on a daily basis. And what the supervisor is looking for is not only to correct unsafe behavior or to congratulate good behavior, but also to verify if the system is effectively doing whatever it's trying to do. So, for example, energy control, lockout, tagout, you have to have a process to verify that the process is effectively controlling unexpected releases of energy. So it exists on different levels, the OSHA as well as the 7E.
Okay. Thanks, John. So the next question is the practicing of grounding out electrical wires on an existing panel, even when power is removed, a good idea in all cases? Charlie, you can start with this.
Sure. Oh, go ahead. Sorry, Charlie.
No, go ahead, John, and I'll pick up. I've got something to say after you.
Okay, yeah, I think the person asking the question is talking about personal protective grounding, and so that's a type of grounding that's a required element for high voltage work. If you're working on high voltage systems, you don't have a choice. If you're going to take your gloves off and put your hands on it, it's got to be not only locked out, tagged out, and tested, but it has to have a visible open in the system, and you have to have a full set of personal protective grounds installed. So at high voltage, it's not nice to do. It's a requirement to do it if you're planning on taking your gloves off. At low voltage, it is very much circumstantial as to whether you're going to do it. Most low voltage systems aren't configured to accept a set of protective grounds. So only usually on things like pad mount transformers would you get an opportunity to put a set of grounds on low voltage systems. But if that's the case, and in all cases, that's again another judgment call. If you're planning on taking your gloves off and touching the equipment, that's the real pass-fail test, isn't it? It's not whether or not you're in compliance, it's whether it's safe to touch it. So, do I put grounds on every single time on high voltage? Yes. Or you're going to play it hot at low voltage. If you're able to do it, it is superior to lockout tagout all by itself, but it's not a requirement at low voltage.
Yeah, this is, and where the confusion probably comes in on this is in establishing and verifying that electrical equipment is in an electrically safe work condition. Yes. There are 8 steps. Step number 8 is installing temporary electrical safety grounds. And when I'm teaching, I'll always say to establish and verify that equipment is in an electrically safe work condition, you're going to do either 7 or 8 steps. And just like John said, typically for low voltage, 480 volts and below, we don't install temporary electrical safety grounds. And if there's a place to do that, just like John said, you have to use temporary electrical safety grounds that are capable to handle the available fault current. There was one factory that I worked in. They had put together their own homemade electrical safety grounding equipment, and it was almost just like a fancy pair of jumper cables, 4 wire total. I mean, the 3 hots in the ground, and that of course it has to have the appropriate equipment. It has to be rated for the voltage at the available fault current. So just sticking on jumper cables, that's not a good idea.
No. And actually, Charlie jarred my memory there. The grounds not only have to be rated for fault current, but for duration. And so it's a withstand rating. So it's more of an engineering function to figure that out. But it's not enough to have just rated for the amount of fault current. It's got to clear in a certain period of time. And if it's not clearing fast enough, you have to derate the cables. And so the engineers who do your arc flash studies would be responsible to do that if you ask them to do it. But it is not only fault current rated, it's also with duration, clearing time. And Charlie jarred my memory there. That's a really important point.
Thank you, John. Thanks, Charlie. Let's go to the next question. What we have here is simply define how the Grace Engineered products meet lockout-tagout requirements, both mechanical, electrical lockout. I think this is a product question on Grace Engineered products. So Grace makes voltage indicators and safe test points. Primarily, the indicators are used for voltage presence indication of the application in mechanical lockout-tagout. So where a task qualified person, for example, the one who is working on the secondary side of the pump or a motor application, can simply throw the disconnect off and visually verify there is no voltage presence through a visual alerting mechanism, and then doing a bump test and verifying the system is not re-energizing and performing the task. So if the same person is doing the work inside the terminal box of the motor or inside the disconnect switch or the panel, then it will become a qualified electrical work, right? So then they cannot completely rely on the voltage indication. So in that case, they need to do the absence of voltage test using test instruments. So we have products which you can definitely connect you offline with, a safe test point that you can mount it outside the door to safely verify the voltage absence with a threshold of less than 3 milliamps or such. Okay, so those are the product related. Definitely we'll address that. If you have more questions, you can ask me or send me an email to that. Okay. So the next one is should PLC control panels also be surveyed when performing a site arc flash analysis or update? John, why don't you start with this?
Okay. Well, typically we don't do an arc flash study on the control systems. Normally they're not real high capacity systems. However, there have been faults that have developed on instrument transformers, like current transformers, for example, that have precipitated arc flashes. So there's a couple of schools of thought there. Most of the engineering studies that we see that people, if we're doing an audit, they typically stop at a voltage level. They usually model down to the 480 volt level. And we don't recommend that. We recommend that you take that down, and it's based on our incident energy exposures, what we normally would engineer to that level. So we're not going to stop necessarily at voltage, because although there have been studies that suggest you can't get a significant arc flash at 208 volts, our experience does not support that at all. We've had tremendous arc flashes that have happened at 208. And so we normally recommend the engineer model down until we think we've got incident energy below some level. Usually we use 10 calories or less normally, but control wiring typically isn't included in the study itself. But if it's connected to something that could precipitate an arc flash hazard, it's going to be a judgment call on the engineers whether they model it or not. If they're not going to model it with the engineering study, then they would defer to the tables that are in the 70E.
Okay.
Maybe Charlie can tag on to that if he needs to.
Charlie, do you want to add anything to that, or?
I'm good with that.
So one thing that comes to mind is I get questions about, say, we have the control systems within the industrial panel, right? So, and also we have the power disconnect on the sideways. So what in case the control programmer or a programming guy who is trying to just access those components, however, he is not actually touching any of those 480 volt systems, right? So in this case, his question is, more so like, hey, I'm just trying to only access only the PLC components, but there is on a side level, there's the power components also housed in the same cabinet. So in that case, do you think they need to follow the safety procedures, or just because I'm accessing only the the 24 volts DC, will I be accepted from following all this lockout tagout in that case?
Yeah, and again, part of that, if you have multiple voltage sources in the same cabinet, we typically, in an industry practice, we typically say glove up for the higher voltage, even if you're not within the restricted approach boundary, basically, of the exposure. So that being said, the term that is used in the codes and other codes is called effective isolation. Like on a pad mount transformer, if you open up the right door in the pad mount, the low voltage compartment is exposed, but the left door is bolted shut. In that situation, you're allowed to glove up just for the low voltage. If you were to open that cabinet and both doors open simultaneously, you'd have to glove up for the high voltage, even though you're working on the low voltage system. Technically speaking, the restricted approach boundary would determine if you're doing non-diagnostic work inside the restricted boundary, that's considered energized work. You'd have to pull a permit for that.
Okay. Thanks, John. Charlie, you want to add anything to that, or?
Yeah, a lot of this would, and you and John are exactly right, that in industrial control panels, quite often someone has to make adjustments to the VFD, the variable frequency drive, and how close are they to the over 120 volts, to 208, 480 volts, and are they within the restricted approach boundary? If they are, then that is considered working on the equipment. And so if not, and a lot of this will it'll come down to doing a risk assessment. Is what they're doing, is it within the safety bounds of what the company wants? If it's not, then they may have to either shut it down, or if they're doing work within the restricted approach boundary and it's energized, which it would be if they're making adjustments, and they might, like John said, they may actually have to get an energized electrical work permit.
I mean, there are some technologies out there, like the sequester type disconnects that will completely isolate the power compartment. That's available in the market. I think a lot of great manufacturers do that. And not only from my side, I think we do the Grace programming ports. By installing a programming port, you can totally eliminate that risk of exposure by bringing the component outside, so you don't need to really open the door as well. Okay. So the next question is there any recourse to push suppliers to provide their equipment with the listing this cost does not fall on the buyer? So John, do you want to address that?
Okay, you broke up there when you said that. I didn't hear what you said.
So is there any recourse to push suppliers to provide their equipment with the listing that cost does not fall on the buyer?
Well, that's actually outside my skill set, in the sense that it's more of a legal question than a code-related question. The push to have listed equipment, of course, is that you know that the equipment you're working on has been tested and it's found safe to use. That's the idea behind listing. But the push for it, I would say, although I'll defer to Charlie on the code part of this, it's more of a liability issue. I think if you have something that's been listed, that's an additional part of the process as part of a hazard assessment. And so when you do a hazard analysis, a formal hazard analysis, if you have a listed element, that's considered an additional safety feature of the system. You know that it's safe to use, especially because there's a lot of counterfeit stuff out there now in the world. So you can buy stuff that's illegal to use technically, even for lockout tagout. So in those situations, that would be the push, I would think, more from the liability side. But I'll defer to Charlie on the code stuff. He's more on that than I am.
Well, there's a question that comes up sometimes. Can't we have the manufacturer do the equipment labeling for the amount of arc flash and the amount of potential energy? And no, you can't. It depends on so many factors, and that has to be done after it's installed. Yes. And of course, John was asking about talking about the legal aspect. None of us three are lawyers. And these other guys may not know, but there's a difference in terms between unlawful and illegal. There's a difference in terms between unlawful and illegal. Unlawful is against the law. Illegal is a sick bird.
I like it, Charlie.
Very good.
Oh, that's really good.
Very good.
I had no idea you were going to learn some additional things besides electrical safety.
That was a good one.
So the next question I have on screen is, does someone have to be authorized to install solar setups if an electrician does the grid tie portion of the work?
This is a licensing question, and this depends on the city, state, or jurisdiction as far as what can a solar installer, what can they work on, what can they not work on. And so that's not addressed in 70E. It's not addressed in the National Electrical Code. When work is done on live equipment, then we do refer back to 70E, and the person has to be a qualified person. John mentioned this with a question earlier. It was talking about this, that anyone, in fact, when in 70E, anyone to do voltage testing, troubleshooting, or measuring has to be a qualified person. And that would be the same thing with working on solar. But as far as the installation of that, it all depends on the licensing requirements in the area where you are.
Yeah. As a side note, Banu, we do a lot of arc flash studies on solar farms, and grounding and bonding is a huge problem on solar farms. It's kind of a separate issue here, but for those that work on solar systems, we've had enormous shock problems. But now generation size capacity now, but that has been a real big issue we've encountered.
So since you guys both touched on the qualified electrical person or qualified person, do you guys mind expanding a little bit on what is that qualified? Is it like anyone who has a test instrument is considered a qualified, or anyone who has a screwdriver access is a qualified? Can you just elaborate on that, please, if you don't mind?
Do you want to go, Charlie?
Go ahead. I'm going to look up and give the exact definition out of 70, which is very close to the NEC, which is very close to OSHA. They're all just a little bit different, but they all have the same meaning.
Yeah, the reason why I'm asking is a qualification is just a training, or a qualification is a hands-on experience or a demonstration of skills, or does it also have to do anything more so with the equipment as well, right? So I don't know. I'm just asking you guys so you can give
in general, while Charlie's looking that up, in general, there's kind of a three-prong requirement to be trained under OSHA no matter what, regardless of the energy source. The first part is a technical training component, which is everything from Ohm's law to how the technical aspects of the equipment works. The safety training component is really where the 70E and subpart S and OSHA fits in. And then that last part is demonstrated proficiency. They have to demonstrate the ability to do it in front of somebody who knows the difference. So you can't necessarily have a millwright signing off on an electrician any more than you'd have an electrician sign off on a millwright. And I encounter that because there's a lot of companies that are doing that. But basically that three-pronged training requirement is a general rule of thumb you can follow with OSHA. And I think Charlie's going to take it to the next level here with the actual code reference.
Yeah, the definition of a qualified person in 70 says it's one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations. They've received safety training to identify the hazards and reduce the associated risk. I get this asked a lot about where do we find a checklist to be able to go through and make sure our people are qualified people. There is none. It all depends, because so many jobs in companies are so different, and it's a vast difference that the company has to come up with some way to determine if their people are qualified people or not. And that would be taking some of the top qualified people to brainstorm, to come up with ideas, and whether it's a written test, whether it's watching someone, observing someone do these items, and there's all kinds of ways of doing it, but there is no checklist of being able to make it plain and simple for someone to be a qualified person. It says you have to, and some of this, of course, the 70 says you have to be taught, you have to understand. Well, a lot of us are qualified persons. I consider myself a qualified person with respect to a lot of electrical equipment, 1,000 volts and below. But most all of that, I have not had safety training. I did not have training. It's working on it over the years. And it's a matter of, I went through the electrical apprenticeship school. I am really the poster child of things not to do when it comes to electrical safety, because I was either not taught what to do or I was taught the wrong thing to do. Mm-hmm. And a lot of this I've learned over the years, even way before I started writing electrical books or teaching electrical seminars or being on the 70E committee. It's just a matter of learning things along the way. I give an example when I'm teaching of a Bulldog Pushmatic breaker box. As a contractor, I went out to do a change of breaker out, and this woman who called said, we have a Bulldog Pushmatic panel. And I had never heard of that. I went to the supply house, bought a 20 amp breaker, went to the house and took out the screw, took the conductor off the wire, took the screw off the bus bar, tried to get the breaker out, wouldn't come out. I finally figured out that there's a center bar, and you take a screwdriver and pop that center bar where it comes up and out, then the breaker comes off. You can put the new breaker in. So I consider myself a qualified person with respect to Bulldog Pushmatic breaker boxes, but I never had safety training on that. I never had training to know how this equipment is manufactured.
So you mean in that point, not only having an experience on that broader scale, you must also have an exposure to that specific piece of equipment on which you're trying to perform the task, I guess. Is that right statement, Charlie? Or?
Yes, someone can be. I mean, this is huge. It's broad. If someone's doing work, a maintenance person in a factory, maybe a small factory, they only have certain machines and certain equipment that they're working on. They don't have to know all aspects of the electrical industry. Having a good idea and understanding of Ohm's law and all of that is absolutely great. But is it necessary? It depends on what they do. It depends on their work. It depends on the process they're doing. They have to be trained and knowledgeable in the equipment or even a work method or process that they're doing. So it's not having a master license does not mean that you're a qualified person. I have seen when I do training, and sometimes after the training we do hands-on, I have seen, quote, master electricians and journeyman electricians when it comes to electrical safety that I did not consider them to be a qualified person. Until after my class, of course. Then they learn.
Yeah, the qualified worker requirements are task specific and equipment specific, and so that terminology is, I throw that out there just for reference, that you can be qualified to do certain things and not qualified to do other things, like Charlie was saying, and it's a requirement of the employer is held accountable by OSHA that they have to know what you know. So there is a test. Almost any training session you do, our seminars really should have a rigorous test after the fact, so that you can demonstrate that at least at a date certain you knew this information. It's going to come up in an ensuing accident investigation or whatever might happen later on. So you really need to know that. So most people don't like to do testing, but it's really there's actually an OSHA requirement for it.
Okay. Thanks, John. Thanks, Charlie, again, expanding that. So the next question is for you, John. So explain the electronic permits, the merits and demerits, because we get a lot of this questions asked. We don't have the people really around, so we need to get this merit permits on the electronic way, like a digital way of doing things. So this also applies to training requirements as well in certain cases. Can you explain what those things are and how?
Are you talking about the electrical permitting?
Yeah.
Okay. All right. Yeah. Well, the permit requirements basically are a couple fold. One is, of course, if you're doing any kind of work beyond diagnostic work, troubleshooting. So OSHA and the 7E kind of recognize that you may have to have an energized reference point to do troubleshooting. So the diagnostic versus repair is typically the pivot we talk about here. So while you're in the diagnostic mode and you're troubleshooting, at that point, you can use voltmeters and things like that to do whatever you need to do to figure out. Now, this doesn't have anything to do with the PPE requirements. This is just saying whether it's a permit process. So up to the point when you're diagnosing the problem, you can go ahead and do what testing you need. At that point, when you've diagnosed the problem, say you figured out you have a blown fuse or whatever, at that point, you're required to lock out, tag out to do whatever you're going to do next. If you're choosing not to lock out, tag out, once you've diagnosed the problem, you've entered into the permit space requirements. The other reason that would precipitate the need for an energized permit would be doing non-diagnostic work inside of the restricted approach boundary. So either one of those two would precipitate the need for an energized permit, but they do give you a fair amount of leeway in the diagnostic mode, whatever you got to do to figure out what's wrong. And just keep in mind that, again, pulling a permit doesn't have anything to do with the PPE requirements. It's essentially compensating for the additional risk of doing energized work. That's what it's really trying to do. And Charlie, if you want to add to that, go ahead.
I'm good.
I mean, as you mentioned, John, only thing is people just go into the troubleshooting mode, and where at that point they decide, hey, this is something that need to fix, which would require a lockout, right? At the point, they know exactly consciously something is wrong. So that's what the people get into this gray area. In most situations, hey, I'm in this mode, troubleshooting, and then I'm going to get to the next level and fix it as well, without knowing that boundary of where they need to stop and go to get that permit.
Yeah.
So that's the kind of thing where people need to be really conscious about while making those decisions, right?
Yeah, and I'll add to that. The training requirements, I should have really mentioned it earlier. The training requirements vary by the kind of systems what you're doing. So, for example, you use a certain set of skills for troubleshooting. Use a different set of skills in some cases for maintenance work, and you'll do even different set of skills for installation. Some of my customers do nothing but install. They do only new installations. Very different set of skills than if I'm going to troubleshoot an old piece of equipment or whatever. So the training requirements are also split up that way, in the sense that if you're a fully qualified worker, you're going to have a different set of skills for the kinds of work you're doing, as well as, like Charlie was saying, there's so many different kinds of equipment that have evolved over the years. I've worked in hydro plants that are 1915, very different than in a brand new facility that's, just installed recently. So that all kind of intertwined. I should have probably mentioned that earlier.
Yeah, I think I really like that approach of basically having that separation between the skill sets, so people know exactly that is what they're qualified to do.
Yeah.
And call for help in going forward and doing the next steps on it. That's really a good idea. Yeah, thanks, John. So the next question is, are there any changes for arc flash rating since 2018? Probably, I would like you to.
I'm not sure what they were talking about, arc flash rating. I would imagine calculations. And the 2018 70E, which is the current edition, the 2021 will be out in probably mid-September. In the 2018, the edition we have currently, it references IEEE, but it does not reference the new IEEE 1584. It references the older version. The newer version that came out in 2018 is not in this edition of 70E because it wasn't quite ready when 70E came out. And it's going to be addressed in the next edition, but there are lots and lots of new calculations, extended calculations, and but it's those calculations are not going to be, unless something changes last minute. Right now, they're not set to be in the 2021 70E. 70 is going to address it. It's going to mention the 2018 IEEE 1584, but it's not going to contain all the calculations that are in there.
So since you answered this question, Charlie and John, I have a follow-up question on this. So what would happen if the equipment has been designed for 2002 edition, which was the previous edition, and now the 2021 comes into play with this new changes to 1584 2018, right? So do the manufacturers or the facilities have to go back and perform all the things to the the old equipment, or how does that really work on the compliance standpoint? Do you want to expand on it?
Yeah, you don't have to retroactively go back and do that. There's a 5-year review requirement on the arc flash studies, and that 5-year review is only as long as you don't make any major changes to your system, or if there are major changes to the system that feeds your system. Either one of those would precipitate an earlier than a 5-year cycle on the review. It is noteworthy, though, that the engineering software that we use to do the arc flash studies does have the latest calculations in it. And so we can still, we write that when we write the reports for the arc flash studies, we point out which version of the 1584 we're using. But the software does have the most current version of that in it now. I just had my latest update about 6 months ago had that in there. So we can use those calculation methods. It's just not yet caught up in the code as to where it's going to be.
So for example, if the facility is going through this 5-year revision time where they'll be doing the arc flash calculations again, instant energy calculations. So if they come across this 2018 edition, then as part of that new labeling requirements for those pieces of equipment, they need to comply with that new calculations like the PPE or other things. True? Is it true?
If they will use, normally we will use the latest version of the calculation methods as long as you have the information. The latest information requires many more fields to be filled in, and you may or may not have that information available to you at the time.
Okay.
What you're required to do technically, the employer is required to make sure that they have accurately assessed the hazards to which their people are exposed, and they've adequately protected them against those hazards. So. And by the way, the changes in the software haven't made really dramatic changes to the calculations in our experience. They've actually been a bit lower, actually. But when we're using the latest fields and all of that, we tend to find the incident energy was lower than it was with the earlier ones. Now, that's just don't take that to the bank that's applicable to every installation. That's been our current experience with it. So the good news, and then there's also another requirement. If you work on systems above 15,000 volts, OSHA got political here, but they've actually, you're required to use a completely different software program called Arc Pro software. So if you're going to be working, like for those that work on solar farms and wind farms, the collector system is 34,500 volts. There's a requirement now from OSHA that you use a completely different software for that process. Or there is a little engineering wizardry we can do in the middle there to use it and extrapolate onto the calculation methods. But that's just a little bit of a back note since you mentioned the solar farms that popped into my brain.
Thanks, John. So the next question is, what requirements, if any, apply to panels that have up to 120 volts and components do not have exposed contacts, example, desktops, etc.? Charlie, this is for you.
All right. Well, let's see. We've got up to 120 votes. We have several things to discuss, to look at. What is the shock hazard? What is the arc flash hazard? With table 130.4DA, that's the shock hazard for 120 votes. The limited approach boundary is 3.5 feet. The restricted approach boundary is avoid contact, don't touch it. So there's really no distance away from it like it would be for 240 vote, 208 vote. Just the 120 vote only is avoid contact. Once you go phase to phase, and there's a footnote below that table that references the 120 vote number, the 120 voltage, because the table on the left side says these voltage levels 50 above 50 to 150 is measured phase to phase. Well, and we don't get 120 by measuring phase to phase. We get 120 by measuring phase to ground. But there's a footnote that references us to that row. Once we go over, if we're going to be 208 up to 750 votes, the limited approach boundary is still 3.5, but the restricted approach boundary is 1 foot. We also have in the tables, in the arc flash table, it talks about that if it's only 120 volts, then there's not, and of course you may have to, you're going to have to do like we talked about earlier, a risk assessment to make sure there's no other underlying problems. But otherwise, there is a section as far as in the top of the table for task, about the third one down or so, that lets us know if it's only 120 volts, then there is no arc flash hazard. You don't have to wear arc rated PPE.
All right. Thank you, Charlie. So next question is three-step contact testing required where PESDs are installed? So I think this is more for me. I think they're referring to Article 120.5, Step 7, which is a face-to-face and a face-to-ground test as defined in establishing electrically safe work condition. Yes, three-step contact is required if you are doing electrical lockout tagout. As I mentioned, if you're performing a mechanical lockout tagout, just throwing a disconnect off and doing a bump test per 1910-147, you don't have to do the 3-point test. However, if the work is performed is electrical work, which is by qualified electrical worker, then the 3-point test would definitely apply. In that case, you can use our safe test points or voltage test station to safely verify that face-to-face and face-to-ground voltage from outside the door. So to just go back and reiterate, 3-point test is a not requirement if you're doing a mechanical lockout tagout, just doing the secondary side of the equipment, mechanical side things, right? The electrical work is done, then absolutely yes, you need to do the 3-point test, or you can do an alternate method, which is outlined by 17E, okay? So do you want to add anything, Charlie, to that, or you're good?
No, I'm good. I like the Grace voltage test station. I like the safe test point. And of course, like any equipment, it has to be or should be installed in accordance with the manufacturer's instructions. But I like being able to test for the absence of voltage outside of the equipment and test phase to phase, phase to ground. I would even go ahead and there was a comment that came up, the question to me one time, well, what if, and there was a scenario, what if one of the, maybe it's a fuse disconnect, one of the blades stuck, the other two pulled out, one of the blades stuck as one of the problems. The other problem is the equipment ground that comes from the safe test point was somehow disconnected or cut. It wasn't there. And so they said, well, then if you're doing phase-to-phase testing, because even with that one that's energized, because the other two are not energized, you're not going to get any power. And then phase to ground, the two that are disconnected, you're not going to get power. The one that's still energized, connecting it to a terminal that is not connected to anything, you're not going to get any reading there. And with that, I just said, well, if you're afraid of that, if you're concerned with that, just make sure one of your, after you're testing phase to phase and phase to ground, also do phase to the equipment or to the screw that's holding that safe test point onto the equipment, and to get your additional safety of ground that is there. So I absolutely like the idea of having the safe test point outside of the equipment if you're going to get into the equipment and not have to wear PPE, or meaning that the equipment doesn't have to be energized. If the equipment has to be energized, you're going to have to be suited up anyway. Yeah. But if you're going to get into a piece of equipment that's de-energized and this safe test point is installed, you could do the testing for all of the 3-point testing, sometimes called the live dead live test. You can test it from outside of the equipment as opposed to opening the equipment up while you're suited up and then testing for the absence of voltage.
Thanks, Charlie. So the next question I have is for John. Are there additional hazards from DC battery banks? If so, what are they?
Yeah, well, sure. I think my experience has been DC battery banks don't get the respect they deserve. I think because we don't really have we don't have the problem of fibrillation with DC systems. For some reason, you can walk into a substation house or even in an industrial facility, and you'll see 250 volt DC battery banks completely exposed. There's unshielded material right there. So the battery banks have three principal hazards. The first one is the obvious one, a shock hazard. Again, direct current systems don't normally precipitate fibrillation. However, what they do is they cause deep burns in the system. They cause a lot of nerve damage, and they are absolutely can and do produce fatalities. The second hazard is the acid in the battery itself. It's not an electrical hazard, but it's literally an exposure, because you're going to take typically specific gravity type tests every month on the battery banks. You're going to from cell to cell. And then the third one is if the batteries are vented, they off-gas hydrogen. And so if you have a battery bank that has got vented batteries on it, it can produce hydrogen. And hydrogen is extremely explosive. It has a very wide explosivity range. So when we're talking about battery banks, we've got an arc flash hazard, we've got a shock hazard, and we've got an explosive hazard from the vented batteries, if they're vented type batteries. Did we lose Banu there?
Looks like we lost Banu.
You can't take a joke, right? I guess he's had enough.
There's a question coming up in a little bit about training. So let's go ahead and talk about training until Banu gets back. Training requirements in 70E are there's a lot of requirements, and yet they're vague as well. So one of the things that it says is, as far as the training has to be, a qualified person has to be retrained every 3 years, at least every 3 years. There's certain things they have to be retrained in. The NFPA 70E, the changes in 70E is one of the things. It also talks about training for test instruments that we typically call voltage detectors. And so knowing how to use the voltage detector, all of that should be part of the training. And there's also a annual training for certain things as well. Lockout, tagout, contact release. It is a requirement for an annual training. So when I talk to companies and say, okay, you do training for lockout, tagout and I'll ask them, how often do you do it? And they say every year. I say, well, just throw in a bit of information, talk about contact release. And all that is what would you do if you think somebody is getting shocked? And I do this when I'm teaching live seminars and out in a plant or industry. And sure enough, somebody almost always says, I pick up a 2x4 and hit them with it. And so which is, and then I'll say, well, all right, if you're going to do energized work, don't let that guy with you and make sure he doesn't have a 2x4 around to gain access to, because if he thinks you're getting shocked, he's going to slam you with that 2x4. And so but there's things that we do have to cover with training. The training, training can be classroom, it can be on the job, or it can be any combination of the two. And 70E at this point doesn't reference webinars. It doesn't reference online training, but all of that is up to the company. It's up to the facility. What do they want as training? And I highly recommend that if a company has an electrical safety policy that has any changes or anything different other than straight out of 70E or OSHA, that those things need to be covered in training as well. John, I know you can add some things to that.
Yeah, well, I mean, again, there's also, if you haven't done work in a consistent 12 continuous months, sorry, I'm stuttering here, that also precipitates retraining. So if you haven't done a task in the last 12 months, you have to self-disqualify, basically. And so it doesn't mean you need to come to another multi-day seminar, but you do need to be working under the direct supervision of somebody who is properly qualified. And as far as this contact release thing, I'm a journeyman lineman in my past, and we had a lot of experience with people getting hung up on these things. I would suggest to you that make it part of your job briefing discussion to identify the location and the number of the switch that feeds the circuit you're working on. Because there are many times I've worked on arc flash studies, we went around the plant and some of the workers, we couldn't locate panels. They didn't know where they were actually in the plant. So make it part of the deal. If you get hung up and you can't let go, the odds of being knocked off aren't terribly good. We linemen have a lot of experience with that. And so normally I would recommend you de-energize the circuit if you're able, and that's the best answer. The 2x4, the rope, the belt, that may or may not work. They even make a dielectric hook, which is what I think they're getting at with this part of the code. My suggestion is to have plan A would be to shut it off. They'll naturally fall off when you shut it off. If you're going to try and pull them off, just you got to have your own protective equipment on, because if you get hung up, if you get us both hooked up, it makes it worse for both of us actually. So
the most interesting thing that I heard, I'll usually ask, has anybody ever been hung up, where meaning you cannot get off yourself?
Yes.
And I talked to a gentleman in class one time when he was a kid. He somehow got on some live electrical, and I think he was on the ground, maybe on his hands and knees, and he could not get off.
Right.
Well, his dog, a Labrador retriever, came running at him full speed and head-butted him off of that. I have two English labs. One of them I could possibly see doing it. The other would, he would just lay down and go, "Oh, okay, just let me know when you can feed me or give me a treat." But how would a dog know to run and bump someone off? I mean, that is unbelievable. But time we're old enough to be working out in plants and industries, more than likely we are knowledgeable of what to do when it comes to electrical safety, as far as releasing somebody from what we think is a circuit that's energized. Mm-hmm. I heard a story years ago when I was teaching for NFPA on their seminar circuit. He was from a gentleman in the class. His brother is an electrical contractor in the San Diego area. And there was the house that was being built, and there was an electric concrete mixer on site that was notorious for shocking people. And so people knew not to touch it. Well, one day somebody looked out, and there was somebody holding on to the concrete mixer with their hands, and one of their feet was bent up, and their foot going up and down, up and down. And so somebody ran out of the house, grabbed a 2x4, swung it, hit the guy in the chest, knocked him off onto the ground. A little bit after the guy gained his composure, where he was still on the ground, he looked up at the guy holding the 2x4 and said, "Why did you do that?" And the guy, still holding the 2x4, because it's not every day you save somebody's life, he said, "Well, I just saved your life," being shocked. The guy on the ground looked up at him and said, "No, I wasn't. I was trying to get a rock out of my sandal." Well, the guy who was going to save the guy's life, he was a bit overzealous. He did what he thought was right, but there's other ways he could have done it. But by the time we're this age, or at time you're working out in the field, you have a good idea. Disconnect power. And with a lineman, you've got less areas to run and disconnect power from. As if it's in a plant, you may have a plug, you can just yank the cord out. You may have disconnects all around, but there are other things to be able to do, especially if someone is down on ground level, things that you can do. So that's in 70E just says that we have to address that we have to talk about that training has to occur every year. Banu, when you decided to take your little break there.
No, I didn't.
And
I apologize, guys. I mean, I didn't take a break. My computer died suddenly and then restarted, and I'm back on. So I didn't take a break.
we went ahead and covered a question that is coming up in a little bit about training.
I got
You
nervous.
just tell us if you want to go.
So one of the viewers from this live session asked a question online, so I'm just going to pose this. Is it considered energized work if panel board MCB is off and adding wire to branch circuit breaker? What if MCB is on and circuit breaker is off?
All right, are you saying that the panel board is on, but the circuit breaker is off itself, that you're trying to add a wire to? All right. As an electrician, as a contractor, this is something we did all the time.
Mm-hmm.
It's not to be done anymore. We talked about this earlier. Both I talked about it, John talked about it. If you are working within the restricted approach boundary, that is energized work. If you have breakers above and breakers below that are energized, although you have one that's off, you are within for 208 to 480 volt panel board, you are within the restricted approach boundary. That is energized work. Then if the company would allow you to do that, an energized electrical work permit has to be filled out. Mm-hmm. But there are times that would absolutely be required or possible to do it energized. For example, at a hospital, if you've got life support equipment that's out of that same panel board that you cannot de-energize, well, fill out the energized electrical work permit, wear the proper PPE for both shock and arc flash, have a plan set out, and it can be done, but it has to be done energized. It has to be done safely. Normally, no, that you're adding a circuit for a receptacle in an office. It's going to be a convenient receptacle. That's not going to be allowed. You can do that after hours on weekends and shut that panel board down to add that circuit to that breaker.
Okay. All right, so we have another question from one of the viewers. Will PPE be required for each electrician working live instead of sharing?
Sharing? Well, the company has to make sure that you have the equipment available to you. Typically, what most of the companies I encounter are doing is everybody will have daily wear, which is typically hazard class 2, which is 8-calorie outfit. And then they'll usually share the 40 cal if unless they have their own version. But normally the company just has to ensure that you're wearing the right equipment when you're facing the hazard. How they accomplish that is another matter. Personally speaking, I would not share rubber gloves. My rubber gloves, I take good care of them. They're very important to me. And if you were to sit on my rubber gloves or something, we'll have words. So I don't share my rubber gloves personally. It's just not a requirement. But otherwise, the PPE can be shared. It's just not always recommended, especially if it's hard to get. So it's got to be available to you. But I do have several companies that will have a series of 40 cal suits in each switch room, for example, that you could use if you want. It's not illegal to have that. It's just that there's reasons that you'd want to have your own set.
Bono, I know where this question has come from. Very recently, because of the COVID-19, because of the coronavirus, it's coming up about, all right, what if I share a face mask or other equipment with someone else, and what do I have to do to clean that?
Yeah.
So it has come up. I've seen quite a bit of information on this. I'm going to read it, absolutely look at it, but how can that equipment be cleaned? As far as a hard hat face shield, a category 4 hood, a beekeeper's hood, can that be cleaned and disinfected well enough? And if so, then it would not necessary for each individual person to have their own. Some of the information I have seen that putting this out, oh no, you cannot share PPE. Where's this coming from? I have seen several things from manufacturers that are saying, oh no, you cannot share PPE. Well, who's going to benefit if the companies have to buy everybody their own individual PPE.
Mhm.
The manufacturers who's selling it to them. So there are certain things like John. I would not share a balaclava, on an arc-rated balaclava. There's certain things that I would want gloves that I would want as far as personal that for me. Other things, if they can be cleaned and disinfected. And just like John said, I teach in a lot of factories that they do have daily wear, typically category 2, and they're not going to share their daily wear clothing. That's they have the arc-rated clothing, shirt and pants that the company has laundered for them every day. Other things, it's up to the company to decide if some of these things they want shared or not. When we're talking, like John's talking about a category 4 suit, sometimes called a moon suit, that's quite expensive. And so I've seen some of these companies now have incredibly lightweight suits. And I have seen where, all right, it may actually be better for to go ahead and buy a very nice lightweight category 4 suit if a company doesn't have the daily wear. Maybe they've got a category 2 bag and a category 4 bag. Well, compared to the category 2 and 4, if you buy both of those or one nicer category 4, I've seen that they're lightweight. They have lightweight. I like the either the face shield or the hoods that have that gray shield as opposed to the yellow-green shield, which changes the colors. And even the category 4 hoods, these are being made now with the shields that are gray as opposed to extremely dark. And so the PPE we have out there now is so much better than 5, 10, 15 years ago. The first arc-rated shirt that I got, it was very heavy. I think it had a rating of 8.4 calories per square centimeter.
Yeah.
But it was like wearing starched burlap. It was just very heavy. They have clothing now that is it's a kind of a lightweight long sleeve T-shirt. The industry has come an incredibly long way since the PPE first started, since it first came out.
Okay. So since you touched on the COVID-19, so what do you guys think of how COVID-19 is going to change some of the work practices around electrical safety, as you guys can think of in the short term? I mean, one of the things is the hygiene, personal hygiene, and then the contamination is one piece, which we talked about, Charlie. So do you also think anything else that would change for good after this pandemic is over?
Well, I think Charlie talked about that from a cleanliness standpoint. And by the way, that was a great point he made there. I forgot to think about that, actually. What I think may be important is if you're wearing some kind of a mask underneath your arc flash clothing, everything from the surface of your skin to the outermost layer is supposed to either be natural fiber or FR, arc-rated. Not FR, arc-rated. And so it's the same problem we have with places that have hair nets. There's kind of a hazard analysis challenge there to say, are you going to wear something that could burn or not underneath your outermost layer of your clothing? And theoretically, I see that as being a problem. If you're trying to wear a mask inside of it, if it's not arc-rated, and it won't be probably in that situation, I see that as a possible hazard. I'll defer to Charlie on the rest of the answer, though. Go ahead.
I mean, my question is more so like that's one of the pieces, right? The PPE is the one thing where there's a great possibility of the contamination and there's infections and stuff. So what I'm asking is how this work culture is going to evolve, because you guys are safety trainers and consulting business, what you do, and you go and visit these customer sites on an on-site basis, and how this thing is going to change, right? So what in case if there is some kind of a technical consultancy or some kind of expertise that you need to provide where you can't be physically available? So are you thinking of any kind of virtual reality or augmented reality coming to space, people using this Google lenses or anything in that technology terms that's going to change this landscape going forward?
It also, for example, a lot of companies just have the hard hat and face shield for category 2 up to 12 calories per square centimeter, but they don't have one for every individual person that's going to ever put one on. They may have a half a dozen of them for 25 people that they would be sharing. Well, all right, so it would be up to the company. If once someone puts this on, how is this going to be cleaned? Can you take alcohol wipes and wipe down the band at the hard hat area and the face shield in front? Is that going to kill a potential virus, whether it's COVID-19 or the flu or something else? Then it's really up to the company to determine what is going to be in their safety policy to make sure this equipment is clean from one individual to the other. And if they cannot determine that, if they cannot come up with an answer, are they going to get a hard hat and face shield for every individual person that could ever put one on? But about a month or a month and a half ago, before all this quarantining started, I was, of course, with my LinkedIn pages and LinkedIn account and Facebook account. I'll do some humorous things on there. In fact, more humorous than serious. And when it first started, it was way before they even started saying anything about wearing masks. I got my arc flash hood. I put my arc flash jacket on. I put class 2 rubber gloves and leather protectors on. I had Linda, my wife, take a picture of me, and I put it on LinkedIn that my COVID-19 PPE kit came in. Now I can go to the grocery store. And it was funny at the time. Unfortunately, it's kind of come down to that.
Yeah.
Linda and I are in Oxford, Mississippi right now. On Saturday, we knew it was coming. We heard it on Thursday or Friday that in the city of Oxford, that if you go into a business or store, you have to be wearing a mask.
Mm-hmm.
And so Linda had one. I didn't. I had to go to the Walmart. It was on a Friday before they started the requirement, so I could get a mask to go in other stores, not back to Walmart, but other stores. If I had my arc flash hood, I might have tried to wear that in, but Linda said, no, you're not. She says, I'm fine to go into a store with that as long as I'm not with her. But great, that arc flash hood would be going in. No mask is really going to keep you from being able to breathe in those fine particle germs. But the main thing is if you cough out or sneeze out, that the mask is going to contain that. If I had the hood on and coughed or sneezed, it's not going anywhere. Mm-hmm. And the other thing it does is keeps from touching my face. So I think that arc flash hood is wonderful to wear out. It's going to look a bit odd, but everybody's looking a bit odd now going out in public with masks on.
Including me, Charlie. Current state, so.
I didn't bring the hood with me, or else I'd show you. If you're connected with me on LinkedIn, go look at some of my past postings. In fact, I started I did a webinar a week or two ago, and I started out by teaching the webinar with that hood on and telling everybody we're doing everything to keep you safe. And of course, it was just more for.
Was it more like a virtual distancing too, or?
Do what?
Was it more like a virtual distancing, not just a physical, right? So it just
it was a webinar, so it was just a joke, and so, but yeah, you can see me wearing a hood or something, and just but right now seems like a pretty safe option.
Sure. So the next question I have is for John. This is for projects which have been completed. How long do energized work permits need to be kept on file?
Well, that'll vary by the company's record retention policy, whatever that might be. Normally, they recommend you. I won't say because there's a legal connection with that. But basically, it amounts to whatever the record retention policy is for the company is what they're going to require it. And by the way, the energized permits are an important thing to have. If you need a permit, pull the permit because it is from a hazard analysis standpoint, the permit is actually compensating for the risk of not locking out. So it's actually, if you need to pull a permit, pull a permit. I think sometimes people feel like if I have an energized permit, I'm admitting to OSHA, I'm doing energized work. And it's like, if you have a legitimate reason to do the permit, they want to see the permit. It's compensating for risk. That being said, the first word in the permit is justification. Typically, you got to justify why you're doing it. But if there's a legitimate need for it, and we've covered what that might be, then definitely pull the permit and retain it. Because again, if you're an OSHA compliance officer, if they're electrical, it depends what their background is. Anybody can become an OSHA compliance officer. You don't have to have specific degrees to do it. But if you get trained at the OSHA Training Institute and you come out, if you came out of a pharmaceutical plant or whatever, you may not be a wizard at electrical. But if you're electrical, they're very specific about the kind of requirements they have about that.
So a follow-up question to you, John, on the same note. So can I use the same energized work permit that's been used for a similar work from the past?
No, it needs to be specific to what you're actually working on.
Okay.
Because again, each setup inside of a facility, even on the same circuitry, can have different arc energy and things like that, depending upon where it is in the system. And so, you really should be pulling the permit where the work is actually happening.
Banu, I've got something to add to this.
Sure.
I saw a statistic years ago that companies that started using an energized electrical work permit, the energized work dropped by 70%, not dropped to a level of 70%, dropped to a level of 30%. Mm-hmm. And this is something and the reason being on that is really the bottom line. Someone high up as possible needs to sign off on that, and they know you are doing live energized electrical work. And if something happens to you, they've got their name right there on the bottom of it. And so typically I wouldn't want to be responsible saying, oh yeah, it's okay for you to change this breaker out in this panel or to put this wire onto this breaker that you just pulled into this panel while it's energized. And because that's not, like John said, that's not one of the reasons for being able to do something energized. And if somebody signs off on that, and something happens, then that person, their name is right there. Yeah. And so and a lot of times too, I'll go into a company, it's happening less and less now, but I'll go into a company and management says, oh, we never do any live work. And then I talk to maintenance people and electricians and they go, what? Yeah. We do it all the time.
All the time.
So it's a matter of, for one thing, understanding what is energized work, what is not, but then what policies are in place in the company. And this energized electrical work permit is, when that was added to 70E, it was a great addition. It takes more time, but it also absolutely saves lives.
Sure. Thanks, Charlie. Thanks, John, for this. So the next question is for John. This is on no arc flash study, and the NFPA table requires you to know the clearing times, but you do not know them. Then what? Is there an easy shortcut to get an incident energy analysis?
No. If you're going to do an energized formal engineering study, you got to have the requisite information to do the calculation. The alternative to that is to use the table that they have in the 7E for estimating incident energy and things like that. But if you're going to do an engineering study, you got to have the right information to do it. And it all begins, by the way, with a short circuit study from the utility that feeds your plant. Okay, so There's a lazy engineer's way of doing it called the infinite bus method, where you just assume the incoming power has an infinite amount of short circuit current. That actually is misleading if you do that kind of calculations in the study. So I only mention this because some of our customers aren't doing that. And if you're going to do the engineering study, you got to have the right information. Now, in times past, they did have a spreadsheet put out that was supposed to have the estimated clearing times of certain kinds of devices, overcurrent devices. But again, you really need to use the actual nameplate data of the system that you're working on, the clearing times. And I'll also point out one really important point here, and that is the maintenance of your overcurrent devices, like your breakers in particular, has to be critically important, because those arc flash studies use the nameplate speeds on the breakers. If you've got a breaker that's been in the closed position for 15 years and you're calling on it to open up under fault duty, the chances of it working at nameplate speeds isn't very good. And so you got to have a really aggressive maintenance program with your overcurrent devices. And by the way, those molded case and insulated circuit breakers are only rated for one reset into short circuit current under normal conditions. So if you reset a breaker multiple times, you become a test pilot. We don't really know what's going to happen there because the breaker is subjected to unbelievable stresses, both electrical and mechanical. So make sure the maintenance is part of the equation when you do the study, because if you haven't got adequate maintenance, the chances of the breakers giving you the proper calculation aren't very good.
So just a follow-up question, John, just because you touched on something, resetting the breaker, can you just elaborate what are those basic requirements when you reset the breaker? Because the breaker trips and someone just tries to go back to the panel and then resets it, right? So do you want to expand on what some of those precautions need to be taken while doing that?
Yeah, well, the 70 forbids you from actually resetting a breaker that trips under fault duty without doing testing first. They don't have that same requirement for overloads, which I think is probably a political negotiation there. But because unless you're standing right there when it happens, you're not going to know the difference as to why it tripped. But what they're getting at is the one trial close rule. You know, flash testing, that was how I was taught, actually. I came up in the 70s, and we actually had a one trial close rule. We stopped doing that because we blew up a bunch of people doing it, so they stopped doing it, and it finally made it into the 70 now. But the reality of it is if you reset breakers under fault duty, you're supposed to do a test to verify the system is safe to re-energize, and that can really be a challenge to figure that out after the fact. But most people will just try to reset the breaker, and they're telling you not to do that because the breaker, well, a low voltage power circuit breaker can handle 3 resets into short circuit duty, but your molded case and insulated case breakers are typically only 1.
Yeah.
And I mention that because when I tell somebody this in a plant, usually their eyes roll back and say, well, geez, I've reset that breaker 10 times myself. You know, the chances of that happening, you just need to be aware of it, because sometimes you read these OSHA fact sheets and, you know, John Kolak, maintenance electrician, resets a breaker, or actually just does switching on a breaker and it blows up. It's not bad luck. It's usually poor workmanship as to what happened there. And so I just mention that because that one gets me excited, especially when I know people have reset breakers multiple times into fault duty.
So the next question I have is, NFPA 70 does not really apply to utility and power generation plants.
Right.
This 1910-269 from OSHA that covers that. So do you guys want to just expand on it? Which specific parts within the utilities would 70E apply, and where the 70E does not apply? You want to just discern between those two, please?
Yeah. You want me to take this, Charlie?
Yes.
Okay. The requirements for what type of system you're working on are based on the kind of system you're working on, not on voltage level. So it's not about high and low voltage. It's about what we call utilization versus supply. Okay. So utilization systems use energy. They don't produce it. So everything on the incoming power into the facility from the utility to the change of ownership, which is the meter, that's all 1910-269. Downstream from that, the utilization parts of the system is called utilization, not low voltage. So in your backyard, you've got a green box back there. It's a 120, 240 volt single phase transformer. That's absolutely supply. But Kohler Company in Wisconsin has 138,000 volt furnaces, and they're absolutely utilization. So it's not about high and low voltage. It's about the kind of system you're working on. So technically 269 is a supply code, and 70 is a utilization type code, as is the NEC. The NESC, the National Electrical Safety Code, is sort of the design and installation part of the supply world. We don't teach it a lot. Looks like you lost your lights there. All right.
Exactly.
Yeah. You notice this is only happening to you. Charlie and I are impervious to this. You seem to be having all the trouble here. But that's actually how the codes are split up. It's not high and low voltage, it's utilization versus supply. That being said, the utility maintenance standard is way behind the curve when it comes to arc rated clothing and stuff like that. So we sort of misapply the code. We allow you to use it because that represents the best thinking we have in the process. If you get lit up in an arc flash event on a supply system, OSHA will use the general duty clause to cite you. 5A1 is the code. And it's a kind of a difficult thing to make stick, but they'll cite you on 5A1 and reference the NFPA 70 that has to do with whatever was the issue, because that represents our best current thinking on the matter, even though it's technically misapplied a bit. And Charlie, if you want to take it further, go ahead.
No, you addressed it very well.
The next question is, we see some facilities think that they don't have a qualified persons in-house to perform the tasks. So the normal way they do it is bringing in the external contractors or the external companies who are capable of doing the work. So in that case, where does that safety line draw? Basically, you assume this person who is coming to perform that contract work is a qualified person, right? And then you bring him to your facility. And where does that liability or the responsibility of that safety falls in?
Well, contractor safety is a loaded question. Once again, Charlie pointed out we're not lawyers. That's probably our best quality, is that we're not a lawyer.
Yeah, exactly. No, that's the reason. That's the reason I made a disclaimer before. It's just an opinion of the speaker or the presenter. It's not.
All right. With the disclaimer that I'm not a lawyer, it really depends on how you relate to the contractor. There's what they call the laissez-faire or hands-off approach. One school of thought is you spend all of your time and effort qualifying your contractors before you let them come on site. And then they do just discrete work, unsupervised. You have no interaction with them other than what you assigned them to do. The other part of it is you can treat the contractor like your own employee. And then they would come into training classes like Charlie and I do, and you actually treat them like they're your own employee, although they're a contractor. So there's no right or wrong answer there. That's, as I said, a legal question as to how much risk you want to absorb. But whoever you have exposed to parts at 50 volts or more, or 1.2 calories or more, has to be qualified. And you just got to make sure that only qualified people are servicing the equipment. Other than that, I would be in over my head legally to tell you anything further from my end of the.
Well, 70E does address host and contract requirements. In 110.3, it's host and contract employers' responsibilities. And so and usually if a company has an electrical safety policy, they usually have it written in their policy that anybody coming on site has to also comply with their policy. And I've heard of plenty of times where the contract employer, these people come on site and they do whatever they want to without regards to 70E, without regards to the company's electrical safety policy. That's up to the host company to make sure they comply with 70E and their own electrical safety policy, and they should be doing the same thing. I've got a good friend who's a contractor that they have been following 70E electrical safety rules for a long, long time. And a lot of electrical contractors, you're probably aware of, they go into places, they don't comply with 70E. Unless they go into an industrial factory that says you have to comply. But if they go into an office building, they pretty much do what they've always done. Just they work on it, energized equipment, energized panel. And this friend of mine his company goes into smaller plants quite often, and their maintenance people, their electricians will look at them, especially if they've never seen anybody suit up. Going, what are you doing? And meaning that when they're in there doing that, they're not suiting up. They're not doing, they're not being electrically safe. So a company really needs to make sure that anybody coming in
Has to have
doing any type of work, whether it's energized work, whether they open a piece of equipment up for troubleshooting, that they're going by 70E requirements and their own electrical safety policy. If there's anything different other than just what we find in 70E.
There's also a side note that goes with that, and that is called existing conditions in 1910-269, but it's also alluded to in the 70E. But the idea behind existing conditions in contractors is if you have anything about your system that's unusual, that a regular journey level worker wouldn't expect to find it there, like an unusual voltage or an unusual frequency or something like that, you have to apprise the contractor of that before you let them go to work. So like if you work on a solar farm, you might have 3-winding transformers, 915 volt systems. I mean, those are weird voltages. You don't expect to see them. There is a requirement under OSHA, and it's alluded to in the 70, but it's called existing conditions. So if you've got something unusual about your facility, that needs to be part of the orientation process. I forgot to mention that.
So in simplistic terms, there is no such thing as a transfer of liability to external party.
Again,
if a person is performing the task at your premises, the facility owner has a responsibility towards that work.
Yeah, that falls on the host employer to apprise the contractor of that. And if the contractor in doing the work encounters something they didn't expect, they also have to let the host employer know.
Okay.
So that we don't figure out.
I've got a good example of that I've heard of years ago. That all right, in the National Electrical Code, in class sometimes I'll ask, what are the required colors for a 12208 volt system? Quite often somebody in the class will say the conductors have to be color coded black, red, blue, and white. I say, okay, what about 277 480? And they'll say brown, orange, yellow, and gray. And I say, well, no. They're not, because I was asking what are the required colors. Now, industry standard colors out there are black, red, blue, and white for 12208, and industry standard for 277 480 are brown, orange, yellow, and gray. But these are industry standard. The NEC, the National Electrical Code, gives requirements such as if a system is a 3-phase 4-wire delta connected system, that high leg, that wild leg, stinger, red leg has to be color coded orange.
Yeah.
But otherwise, the colors can be just almost whatever. I've heard about a plant in North Carolina where those color codes are exactly opposite of industry standard.
Wow.
So for 12208, the colors are brown, orange, yellow, and gray. For 277 480, they're black, red, blue, and white. And that's a great example of what John said. If you know your facility has something different, would not be normal out in the field, you have to let outside contractors know about these things. And I think that's a great example.
It is.
Of what I've heard out there from students.
So the next question here is, how can you justify replacing old electrical equipment based on safety? So I think I will take this partially, then probably I will ask John or Charlie to answer on that as well. So I think electrical equipment maintenance is one of the predominant things when it comes to safety, because you need to understand the equipment condition, as John and Charlie was explaining before, the condition of the equipment, because you don't want to expose your personnel or your contractors to the hazards. So you need to make sure that equipment maintenance is taken care. And there is a standard that's out there, which is NFPA 70B, which is a recommended practice for electrical equipment maintenance. And also the other standard is the ANSI NETA maintenance standards, which is a MTS document, which gives the specific guidelines on what those maintenance parameters for those specific equipments are, like the motors, transformers, switch gears, control panels, and such. So, I mean, most of the times when you look at the 70E, you have to also follow the manufacturer's recommended guidelines when it comes to safety, because while I think there is Article 130.2 within 70E, which talks about a normal condition. The normal condition of the equipment exists when you meet those 6 specific criteria, like the doors are closed and the equipment is properly maintained, is one of those criteria when it comes to that. And yeah, I think definitely safety maintenance plays a bigger role when keeping your personnel safe at your workplace. And John and Charlie, do you guys want to expand on that? Anything?
Well, one thing I would suggest is that if the short circuit current in your facility changes, or for example, if you replace a transformer with at least a 2% difference in impedance, your fault current can go up. So you may have had a system that was engineered properly 25 years ago, and this fault current has changed in the system. So now the system's over duty, so to speak. It can't interrupt the fault current to which it's subjected. And by the way, once again, those are withstand ratings now on your breakers, just like your conductors. It's not just short circuit current, but that's a very common thing to happen is when you change the system internally with, for example, going from a delta wound system to a Y wound system. In those situations, you can often get a significant increase in short circuit current.
Okay. Thanks, John.
Change something out based on safety.
So the next question is for you, Charlie. How often should safety training be held and why? And then the follow-up is, shouldn't training include ability to read electrical drawings and be able to associate drawings with installed systems?
This is part of this question we covered when you were taking your long break. Well, I know you said you didn't take a break, but we don't know if you did or not because your screen went blank. We covered training has to be at least every 3 years. And the other part of that, does someone have to be able to know how to read schematics and blueprints and all of this? That you do, that may be what someone does know, but as qualifications, does the company require that for the person to be a qualified person? And more than likely, that answer may be no. And so there are no specific detailed requirements saying that, oh, you've got to do this and this and this before you can be designated as a qualified person. And so it's no real easy checklist to go through.
Yeah, if you're required to read a schematic to do your job, then yes, you need to be trained in it. If you're not, then no. So I mean, it's not harder than it needs to be. If they need to read a schematic to do troubleshooting, for example, they would need to be trained in that, but only if they use it.
Thanks, Charlie. Thanks, John. So the next question is, 70E talks about the risk control hierarchy with the multiple elements like the elimination, substitution, engineering controls, awareness, policies and procedures, and then the PPE, right? So, right. And then to add to that, when you take this elimination or engineering controls or substitution techniques, there are so many technologies out there, right? So what is your opinion when it comes to different technologies? Using one will make you not use the other things? Or, for example, you have a remote tracking mechanism for breakers, for instance, right? And then you have the PPE. So do you need to not use the PPE if I'm doing that? Or what is your comments and thoughts around it? Because is there like a silver bullet when it comes to safety?
Well, I'll take this one. Again, you're laughing because you know what you've done here. I'm glad I could be available to you for your fun and entertainment. It's going to come down to formal hazard analysis is what it's going to amount to. And when we assess hazards, we assess both hazard severity, which would be defined as the worst credible outcome that could happen from the energy source being evaluated. And the other side of it is called hazard probability. So as it turns out, when you look at the hierarchy of risk controls, the probability that if you're at the very top of the food chain and you would have a negative event happen, that probability establishes what they call due care. And as you work your way down the hierarchy, it gets less and less effective. So you're going to notice you have to start overlapping hazardous, and it's all about probability here. It's the idea of winning the lottery. The chances of picking the first number is 1 in 10. Getting all 6 is 1 in 32 million or so. And so what it amounts to is you'll notice that as you go down the hierarchy, in other words, if you can't eliminate it or do substitution or whatever, if you're down to PPE or procedures, that is the lowest form of protection other than doing nothing at all. And so as it turns out, you're going to notice they overlap, like interlocking your fingers. So I had a friend who got lit up. He lost his right arm doing some maintenance and troubleshooting work. He had to violate 5 rules simultaneously to do that. That's the way you'll notice that the redundancy in the rules is like winning the lottery. It's about probability. So if you go to plan A at the top of the food chain, that's usually a little more expensive to implement, but it's much more effective than trying to get procedures and policies and PPE. Because if you're using administration controls, you're going to basically have to have tight supervision, and you're going to find the total cost of the process actually is more expensive to manage at the low end than at the top end. But initial cost, no; long-term cost, no question. It's not even close. It makes more sense to do elimination or engineering controls rather than PPE and procedures.
Okay. Thanks, John. So the next question, probably Charlie, I will give to you. So what are some best practices for ensuring safety while replacing main switchboards or distribution panels on older buildings?
All right. I would say it's going to come down to putting the equipment into an electrically safe work condition, which we have talked about numerous times. And in 70E, this is discussed in section 120.5. Mm-hmm. We have 7 or 8 things we have to do. And that's the one we talked about. Step number 8 was installing temporary electrical safety grounds. Mm-hmm. All right, so you've got a 480 volt system or a 480 volt switch gear coming in and you're needing to change it out. Well, we absolutely have to check all of the voltages coming into that. And I'll go through all of that list as far as putting all of that into an electrically safe work condition. Mm-hmm. Years ago, I read a forensic report about a company that was changing out MCC, working on an MCC motor control center. And one of the guys, there were 2 electricians in the room. One was working on the equipment. The other had gone around to the back. And 70 also talks about do not do what's called blind reaching, where this one gentleman put his hand behind a panel, and they had turned off the 480 volt system that was supplying power to that MCC, but they had not turned off the control voltage, which was 120. Yeah. So the guy put his hand behind a panel just to hold on, or just to just have his hand up there. There was 120 volts behind there that his fingers touched. He could not get off. Mm-hmm. And then he fell and hit the floor. The other gentleman that was in the room heard that. It was too late. He'd been electrocuted. He died from putting his hand up there. So there was kind of like John was saying, there were several things that went wrong at that point, overlapping multiple things. They should have turned off all the voltage to that. This gentleman should have absolutely never do what's called blind reaching, whether you do it on purpose or accidental. We were taught in electrical apprenticeship school to put one hand behind your back, right? Yeah. So not to touch something grounded or have your hand go touch something that is energized where you can't get off. So these are things that we have to understand. What are all the voltages coming into this? And if you're working at maybe a commercial building and you're working on a piece of equipment, there could possibly be something backfeeding from another system into that same panel board. So you absolutely have to eliminate all the hazards and put the equipment into an electrically safe work condition, which there are multiple, either 7 or 8 steps that you have to do to establish and verify an electrically safe work condition.
Thanks, Charlie. Thanks for doing that. So our next question came to the viewers, one of the viewers online. Could you explain why infrared windows do not void the UL rating of an electrical enclosure?
That would be Charlie's.
I didn't understand.
Basically, it's asking if the infrared windows are used within a switchgear or MCC buckets for IR thermal scanning, how does they not void the UL certifications, right? So I think the question in simplistic form is, I have this panel that's been listed to 65 kA short circuit capacity, and I have this certification requirements. Now, as a new practice of predictive maintenance or preventive maintenance work, we're trying to put those windows on top of these panels. So how come they will not void the listing requirements of the panel?
Well, that's a good question. I would have to talk with the manufacturers of the windows, and there are different versions that are out there. Some of them are the big wide. It looks like glass, but it's not glass. And then other types have very small metal plate that have the small holes in them with maybe even plastic behind there. Mm-hmm. So may have to talk with the manufacturer of the equipment, with the manufacturer of the IR windows. That's where I would, as far as where I would at least start.
So I mean, at least from my experience talking to some of those manufacturers, I think the windows must be rated for that specific short circuit current rating. So if you're having a panel that's 65 kA, and these windows must have to meet that requirements of that listed for that 65 kA rating, then you put that on it, and in a closed condition, when all the screws or bolts are closed on that window, then yes, that window will not void. But you need to be really, really careful on making sure that the window that you are using are of the same rating as your panel board rating is to start with. And then second thing is, whenever you make any type of modifications to the panel, John or Charlie, you guys can correct me if I'm wrong, has to go through some kind of a recertification requirements so that the original equipment integrity has not been compromised. Is it true?
Yeah, and in fact, the manufacturer, and at least in my experience, if you're going to retrofit something, they would actually have to provide the criteria, the materials, and the process in place to get it recertified. So the integrity there, I forget the numbers of the standards now. C20 something.
C27.2 or something. Yep.
Okay. Yeah. Thank you. The idea behind that is it has requirements for the size and the integrity of the walls, versus the doors, and things like that. It has to meet all that criteria. Process has equivalent integrity that it would have had you not cut a window in there. But I will also say, though, I know there's huge liability if you field modify anything. So it would have to be something that the manufacturer would sign off on, and have your own PE sign off on it as well.
Okay. Thanks, John. So next question, Charlie, what types of labels, safety related, does a control panel must have? And the follow-up is, does the safety circuits require a different cable color?
All right, we've got a couple of things to the labels. 70E requires equipment warning label. That's in 130.5H. Also, we have, as far as labeling requirements in the National Electrical Code, for example, a legend in a panel board, it needs to describe in a manner that you'll be able to figure out which circuit it is. And it also, and that's in 110.22A, and it goes on to say that it cannot be in a transient condition of occupancy, meaning if it's in an office building, Bob's office receptacles and lights would be dependent on transient occupancy. If Bob leaves and someone else comes in that's not named Bob, then it's going to be hard to figure out whose office is that. So that's an installation requirement. We also have requirements for for a disconnecting means. What does it, for example, where does it come from and what does it supply? Unless the supply is obvious. For example, if they're out of a disconnect or safety switch, there's a flexible metal conduit or seal tight going down to the actual equipment, then it wouldn't have to be labeled because it's obvious where it goes. The requirement for the colors, for white on red background, black on orange, and in the yellow background, these are ANSI requirements, ANSI Z 535.4. And that would be covered in the product safety signs and labels. And so we have a couple of kind of broad areas that this question reference, but that'll give you a quick idea of at least some directions to go. And in the National Electrical Code, it talks about the signs and labels in I think 110.25, I think.
Thanks, Charlie. So the next question is for you, John. Is energized work permit required to work in a panel that the highest voltage is 120 volts AC? All terminations are touch proof?
Well, normally you have to have an exposure in order to have a hazard. If it's touch safe, meaning that it's like an outlet or a plug or something, I wouldn't think you'd need to pull a permit for that. If there is an exposure at 50 volts or more, yes, and you're doing work that we talked about earlier, then it would need a permit. But if it's touch safe, at least from my perspective, I don't see a requirement for that. Charlie, do you have a different perspective there?
No, I've got nothing to add there.
Okay.
Thanks, John. So the next one is for you, Charlie. Do 480 volts panels require door interlocks with the disconnect switch? And then, is there a consensus regarding wire colors within industrial control panels?
I don't know of any, as far as the National Electrical Code, there are no, we talked about that color coding a while ago.
Yep.
There are certain areas that, yes, certain installation types that have to have color codes. As far as the conductors, most of it is wide open. I don't know of any industrial control panel configuration that, there may be some industry standards out there. I haven't seen any of that. I've seen just all types of colors for that. As far as any kind of a door interlock, that almost depends on the manufacturer. I've seen some that you can just absolutely open with everything being energized. Typically a safety switch, a disconnect switch or safety switch cannot be opened while the handle is up, while it's energized. Some of them, I know the older ones have a little opening in the side where you can put a screwdriver in and turn it to be able to open the door. I'm not sure if the new ones have that same override for the interlock as well.
Thanks, Charlie. So the next question is, during equipment normalization, what is the safe way to do if the breaker did not close after initiating remote close command in? John?
Well, when you say normalization, what are you thinking there?
So equipment normal condition, when you're trying to close the breaker,
yeah,
and you're doing a remote close command in, and the breaker did not close due to that. So what do you do what's the safe way to do after that? What are some other things that they should be doing?
Well, I guess it's not so much a code question as I think a work practice issue. I guess if I was going to do that, I would first of all reverse the trip signal, so we leave it in its normal condition. I'd make sure that there's no load associated with it. If the breaker closes in on a circuit that has integrity but not loaded, then if it should close unexpectedly, that limits the risk there. Then the other part is to identify the control circuit and figure out what went wrong. Why did it send a trip signal that the breaker didn't actuate, or a close signal in this case, or what might have happened? So I guess I would make sure the circuit was unloaded anyway if it's new, and because we generally assume failure, we anticipate failure, as they say, for any piece of equipment that we install for the first time. And that would also especially be true of things that have a coil of wire in it, like a motor, a generator, a transformer. So I would always set the system up so when I energize it, I energize the least possible amount of it I could and add circuit parts as needed later on. So I guess I would reverse the signal to close, make sure the system is isolated so that if it did close unexpectedly, it wouldn't affect anything. And of course, everybody would have to play it like it's energized. And again, I welcome Charlie's input here from the worker side. If you do something else, I'd like to know that.
More like a work practices, best practice, the code requirement, perhaps.
Yeah, and it is circumstantial. It also depends on what we know about the equipment. I work with some equipment that I knew it was a piece of crap. Other stuff had a good history with it. And so, you kind of know a little bit if you work with the equipment for a while, what its typical history is. But that being said, it's going to be very much what you experience on that particular moment as to what you're going to do in what order. It depends how it's configured. And
So
I feel
yep. Next question is for you both. Is the supplier or end user of electrical control panels required to provide the proper arc flash calculations and labeling?
Well, only the people who use it could do that. Charlie already alluded to that. We've had requests for people, from manufacturers, to put an arc flash label on their equipment, and of course you can't do that. It depends on what system you plugged it into. So it can only be done by the end user. They have to know what the system is it's connected to.
Again, the light went off.
The electrical code has been requiring an arc flash label for a while, 110.16, and for a long time it had to be basically a generic arc flash label, warning arc flash hazard. It may say some other things, but it was a very generic label. In fact, when it first came out, for the 1 or 2 editions, it said it had to be field installed. And so they did go ahead and change it that it could be factory or field installed, because what they were talking about, what the NEC talks about, is as far as a generic label, is just there's no information on it.
No,
like a 70E arc flash warning label.
Yeah.
And so yes, absolutely, that could be installed in the field, in the factory, it could be put on it just anywhere. But we do have requirements that are, and we mentioned this earlier, that the manufacturer of the industrial control panel or the equipment cannot do all the warning labels on it, because they don't have all the information that would be at the end user site. All of the data that goes into an arc flash analysis, and so that can only be done when it's installed at the site for an end user.
Right.
So next question is, again, putting both of you guys on spot. This is from me. So you guys have these 2 maintenance practices. One is more like routine time-based maintenance, and there is such thing like a new technology is condition-based monitoring, more like using a predictive tools, or a maintenance on demand as the method to approach this problem, because we see a lot of shortage with the skilled workers available in the field today working in the industrial settings. So people are trying to go with this digital trends using condition-based monitoring tools to remotely monitor the status, right? And then there is this 70B maintenance standards, which tells you, hey, you need to do this like once in 3 years or once in 5 years, or when the time permits, around those lines, right? So what is your thought around maintenance-induced errors? So do you guys think there is a possibility that, hey, I'm trying to perform a maintenance task on this piece of equipment, and then as doing that, I'm inducing a failure point? So do you guys see that's a possibility, and how do we overcome that? I mean, where do you drive the balance between a condition-based maintenance schemes versus something that needs to be done on a routine basis, no matter whatever my condition says, based on the parameters, I need to do this? So where do you draw that line? I'm laughing just because I know.
You want to go first, Charlie?
A lot of what I see in factories is these maintenance people, these electricians, are putting out fires. They're repairing things as they break, and they're going as fast as they can doing that. There are companies that absolutely would like to add a preventative maintenance scheduling on their equipment. Some are doing that. I would say at least most places I know that I talk with, most places where I teach, it's the staff is about as small as they can be in numbers. And probably with all this COVID-19 stuff that's happening out there, those people they're probably fewer now than there even were 2 or 3 months ago. And so most of what I see are just they're repairing things as they break. not having really enough. They don't have the time to go out and open panel boards up, and some equipment absolutely has recommended practices for maintenance, and there's other equipment that like a panel board, like a piece of equipment. John was saying it's been sitting there for 15 years, and how is this stuff going to work? And regular molded case circuit breakers, we don't have the testing for those. They're working or they're not working, or we have all heard of times when breakers have tripped because of maybe it was an overload, but more than likely, no, it was something else. But the maintenance people, the electricians, go and reset it anyway.
Right.
No telling how many times. And so so does a company, do they go ahead and implement a preventative maintenance? And right now, companies have been running such fast pace trying to make products that it's a matter of just fixing what breaks at the time.
Yeah, the hierarchy, from a regulatory standpoint, the hierarchy is always do whatever the manufacturer recommends as the maintenance procedure first. Secondarily, if you can't do that, then using the tables in the code for maintenance on various systems would be next. The third level would be using a PE or a CSP to sign off on it. And then after that, you're kind of winging it. But he's right. Most companies don't do preventative maintenance. They just do maintenance as it breaks, as Charlie was saying. However, part of the 70B is trying to help people understand the cost benefit of doing a maintenance program. So there actually is money to be made doing that, and especially when you consider the safety part of it. The other part of it is, by the way, the required maintenance, like at the end in the annexes in the back, especially with larger breakers. They used to have a 1200 amp limit on it, but if you're using breakers larger than that, you're not only supposed to do the maintenance, but we're supposed to do some engineering wizardry there to try and lower incident energy if you can on larger circuits. At a minimum, I would exercise your larger breakers probably on an annual basis, meaning just open and close them, not under load. But when we do that are seized in the closed position, they snap the tongue off on the breaker. The handle gets snapped off because they can't operate the breaker, and I think they take a crescent wrench to get mechanical advantage there, and they snap the thing off. So there's been situations where if we left that breaker in the study, it would falsely bias the incident energy at being much lower than it really would be if you had a breaker that was seized in the closed position. And we encounter that surprisingly often doing ARC studies.
So the next question is for you, Charlie. 50 volts DC and below circuits still exempt from the arc flash PPE?
Well, with 70 talks about, the answer to this one's basically no, because this question is saying 50 volts and below. No. Well, the 70E talks about below 50 volts and 50 volts and above. So 50 volts and below, as long as there's no other underlying problems or special types of problems that could cause hazards, then normally that is safe. And for about one addition in 70E, the voltage threshold for DC was less than 100. And this went kind of back and forth, and the committee decided to bring it down, although there were a lot of experts saying that it's safe below 100 volts. DC is safe, and it's just and John was saying it can create burns and things, but the committee kind of looked at our representative from UL, from OSHA, and said, "What would you do?" And David from OSHA said, "Well, if there's a problem, OSHA is going to say it has to be less than 50 volts, not 100." And so the committee decided to go change the voltage threshold for DC back down to less than 50 volts DC, just the same as 50 volts AC.
Yep.
Thanks, Charlie. So next question, I think I'm going to take a couple of more questions, and then probably we'll close this live streaming, because I think I still have about 20 questions to go. And I think we will be standing here all day, I guess. So I would love to do that, but I don't want to start doing it. The next one is for John. Is there a reason that no OCPD is normally installed on secondary side of pad mount transformers outside of MCCs?
Yeah, well, yeah, most of it's probably cost. You're going to have a disconnect on the source side of the equipment, and putting one in the. Actually, if I had my choice from the engineering side, I would actually have the one inside the pad mount myself, because you got to take into account the incoming source conductors in any kind of like an pad mount transformer installation. And so be aware. I think it's important for the listeners to be aware, especially from the testing standpoint. If you take voltage readings on an incoming breaker, if you take it on the source side of that breaker, it's the same thing as being in the transformer. And so if you're going to take voltage readings, for example, on an OCPD, I would always take them on the load side of that if you could. That being said, the primary driver for it is cost. If you have a pad mount transformer, the breakers are often somewhere in the neighborhood of $8,000 to $12,000. To have two of them in series is unusually expensive. And there'll be a requirement to have the breaker inside the switchgear itself, or within so many feet of the switchgear itself. So the driver for it is typically cost.
Okay. Thanks, John. So the next question is for both of you. So what retrofit solutions are available for arc flash reduction at sites with simple molded case circuit breakers?
Retrofit solutions. Well, I mean, on typical molded case circuit breakers, it would just be a different kind of molded case breaker. If they have electronic trips, we have a lot more choices. And if the breaker is actuated remotely, that also gives us more choices. So we can use light curtains, all kinds of different things for zone protective equipment, differential tripping. We can do a lot of things differently if you have electronic breakers. With molded case breakers, other than replacing it with a faster molded case breaker, I can't think of anything we could do retrofit wise to manage it unless you put in an arc flash switch, which is it's a series mounted switch that's actuated by a relay. But other than that, I can't think of anything else that we could do on a molded case breaker.
Sure. Thanks, John. So the next one is again for John. What should be removed last, the safety grounds or the lockout tagout?
You'll take the grounds off first, and then you'll take the lockout tagout off.
So lockout tagout is the last one that you take off. Okay, that's.
And when you take one of those grounds off, you got to play the jumpers themselves as being energized. So if you're putting grounds on, it's always going to be done with sticks. Don't ever put a ground on by hand.
So again, I'm just going to put this disclaimer back again. All these opinions that are expressed are just the presenters only. And if you need any kind of further discussion about your unique safety needs, you need to reach out to them directly. And I'm going to put their contact information here on the screen. Charlie's email, John Kolak's email, and my email are on the screen. And again, if you have any further questions about this live stream or anything technically you would like to clarify with John or Charlie, you can reach out to them directly. And if you have anything to ask of me on the Grace products, you can reach me as well. So again, thank you so much, John and Charlie, for joining our live stream this morning and spending 2 hours just talking about safety. And I'm sure most of the viewers would find it very, very interesting. And yeah, with that, any other closing thoughts, John and Charlie?
I'm good. Thank you for having me. Thank you for submitting questions and hearing our answers.
Yeah. Yeah. Also, thank you for the opportunity. I hope anything we said was helpful to you, and feel free to send us questions if needed.
Sure. And also this live stream, the entire thing will be recorded and will be also will be available on Grace Engineered Products YouTube channel. You can go and watch it later if you have time. Yeah. Again, we'll definitely reach out to you on this. Again, thanks for joining our webcast this morning, and please do follow us on LinkedIn, Facebook, and YouTube Live for you to just stream the good content, because we have a lot of experts like Charlie and John helping us to promote the electrical safety message to our audience, and we would love to hear from you guys. Okay, thank you so much again.
God bless.
Thank you.
Thanks.